For those of you who are familiar with IPv6, you'll be well aware that it has built-in support for gateway load balancing or gateway redundancy. And this is accomplished through those router advertisements. Notice here that we have R1 and R2 that are connected to the exact same local area network. And both of them are sending router advertisements. However, RPC has received the router advertisement from R1 first. So it was essentially a race. R1's RA made it to the PC first. So R1 is stipulating that it's going to use R1 as its default gateway. So since it's using R1 as its default gateway, the router advertisement from R2 will not be discarded. The PC will make note that there is another default gateway that's possible, and that is using R2's address. So what are these addresses? They're link local addresses that are being utilized. So when the client now needs to send traffic to this server that is beyond the local area network, it is sending a neighbor discovery message to get R1's MAC address that is associated with the link local address that it has set up as the default gateway. So even though it has R2's link local address reserved as a default gateway address, it won't use it unless it no longer hears those router advertisements from R1. So once it ceases to get RAs from R1, it then uses whatever default gateway address is next in the list. So in this case, it would be R2. But how long could this process take? For example, from the time the PC stops hearing router advertisements, it could take 40 seconds. 40 seconds, that's about the default. So failover time here is not all that quick. But you can fine-tune the timers if you want to. You can fine-tune the timers so that way their router advertisements are set to every 1 second. So therefore, theoretically, your failover time could be just a little over 1 second for the default gateway. But what if you're in an environment that needs sub-second failover? Well, if you're in the environment that needs sub-second failover, there's no way you can reliably tune the IPv6 first hop redundancy features, those router advertisements, to less than a second. So you can't tune them enough to give your environment the sub-second convergence that it might need. Not only that, what if you're relying on DHCPv6 for IP addressing information, as well as all the other information that comes along with DHCPv6? Well, those router advertisements aren't being used by the end stations anymore for the addressing. As a result, they don't have the information they need to perform this IPv6 built-in redundancy. So when we use our first hop redundancy protocols such as HSRP and GLBP for IPv6, right, we have the ability to control who is currently the forwarder. We can preempt. That way there we are always in control of who is currently forwarding at that point in time. We can fine-tune the timers. We can set up tracking, which we can't do with the IPv6 first hop built-in redundancy mechanisms. It's just not as robust as using HSRP or GLBP. So keep that in mind. Just because it has that ability to do the redundancy, the availability, so on and so forth for the default gateway with IPv6 built in, it's not giving you everything you could possibly have with the first hop redundancy protocols.